Hello and welcome to section 11.7, which is on the areas and volumes of similar solids. So similar solids, they have to have the same shape and all their corresponding dimensions have to be proportional, otherwise they're not similar. Theorem 11.2 is the theorem that tells us the formulas we're going to use. So areas and volumes of similar solids. If the scale factor of two similar solids is a to b, then the ratio of their areas is a squared to b squared. And the ratio of their volumes is a cubed to b cubed. So we need to use that to go ahead and try to solve this example that I have here. So what is the scale factor of two similar prisms that have surface areas of 144 square meters and 324 square meters? So in other words, what we have there is a to b, or a squared to b squared, right? We have 144 over 324, and that is their surface areas. So that's a squared to b squared. Now I don't want a squared to b squared, I want a to b. So how am I going to turn this into a to b? I have to undo the square, which is square root. So if I square root 144, I get 12. And if I square root 324, I get 18. And then scale factors, normally you reduce them as low as they can go. So this would reduce to 2 to 3 for my scale factor, my original scale factor. Then I can also use that information to do something with the volumes of similar solids. And so the example that I have here is the volumes of two similar solids are 128 cubic meters and 250 cubic meters. The surface area of the larger solid is 250 square meters. What is the surface area of the smaller solid? Okay, well, I have a problem here because, first of all, I'm given the volumes and I don't have the scale factor. So first thing I need to do is figure out what is the scale factor. So 128 over 250, but keeping in mind that that is a cubed to b cubed. That is not the scale factor. So first of all, realizing I'm going to have to cube root, and I want this to come out correctly, I'm going to have to, first of all, try to split this into numbers that I can actually cube, right? So if I divide both of those by 2, I should get something that I can cube then. So if I reduce it to 64 over 125, I could then cube root that. Because the cube root of 64 is 4 and the cube root of 125 is 5. So the scale factor is 4/5. Okay, so I can use that then to figure this out. So that's of the original ratio, right? But now I want to turn it into the surface area. So I'm going to have to square this, right? Because it said a squared to b squared. So 16 to 25 is going to be the ratio of my surface areas. So I have the smaller, or excuse me, no, I have the larger one, right? 250 is the larger one. And I want to turn it to the smaller one. So I'm just going to take it times 16/25. If I had the larger one and I want to turn it into the smaller one, or excuse me, the smaller one to the larger one, I would have to flip this ratio to make it bigger. So I can reduce this. 25 goes into 250 10 times. So 10 times 160 would be 160, and it's square meters because it's surface area that I'm looking for. So I'm using these formulas today. So bring that knowledge with you, and we will talk more about similar solids the next time I see you. Have a good night.